Okay, yesterday we were continuing our discussion about files, and we realized that in order to write out Java objects, we were going to have to basically write out their component pieces somehow. In this case, into line-oriented text files, and then read them back in at some point by doing exactly the reverse, going and grabbing a line at a time and figuring out what the component pieces of the line are and making a new Java object, and then dumping the object onto a list. And the one thing that we discovered that was a side effect was all of a sudden, if you did it that way, you lost this idea of identity, that double equals no longer worked for you because the object that you read back in was done with a different new and therefore was a totally different one than the original. Okay. You still end up keeping the idea of similar to, so the dot equals method would work just fine. But if ever your program depends on exact identity for things and you want to keep the number of copies of things that you have down to a minimum, then that's a little bit of a problem. Okay. And the other thing that we discovered was if you have to do this for Java objects all the time, it's just painful. Because if you can imagine something like that baseball game that we had with however many variables it was, like 10 or 15 variables in an object, then you're basically writing all this repetitive code over and over and over again with just differing fields that you put inside the objects. So it would be nice if there was an easier technique for writing out Java information. So let's try something that's just a little bit different. And what I'm going to do is I'm just going to dig out a piece of code here, and then I'll explain a bunch of things that are happening with it. So here's this old piece of code that I have lying around. It uses this thing called a character set. And notice that this character set stuff, the import statement is coming from Java NIO. NIO is the replacement IO facility from the original that was in Java. And so they took the original and they said, well, it's got some problems with it. Let's make a bigger, stronger, faster version. And so anything that you see in the original Java IO stuff was java.io, and any of the newer stuff is java.nio for newer IO. So bigger, stronger, faster, essentially. And one of the things they came up with is this idea of character sets. So in this case, you can see that we're interested in an ASCII character set rather than the Unicode character set, so writing more or less traditional files. So we'll do the import statement for that. The next interesting thing is we'll see that this thing uses a new buffered writer. If I'm lucky, I can replace that with new file with file name, just like we did before. So we'll dig one of those out. So here's where I had new file based on file name. So I'll steal that and plop it into there for my file stuff. And then there's a couple of extra classes we haven't seen before. So there's the files class, plural, and there's the buffered writer class. Just looking at this and trying to figure out what it's upset about. Yeah. We'll fix that in a second. IO exception, let's do the import statement for that. And this is something we'll figure out in a moment. Okay, so let's see if we can fix this problem. If I'm lucky again, I might be able to say new path into the import statement. And that almost works. Oops. What did I do? I was trying to see what it's upset about. Oops. Okay. For write one student, I'm just going to steal a whole bunch of previously written code, which is going to be no surprise to you. So here's write one student. It takes a student and a buffered writer object, which we'll figure out in a moment. But notice I'm basically doing the same thing that we've done before. I'm grabbing the first name, last name, age, and formulating them into something, and then proceeding to write it out. I was looking, did I use the wrong group of code here? Yeah, sure enough, I did. Sorry, I've just got multiple lines of goodness in here. Let me try one more time with a slightly different version. There we are. This looks a little better. I'm going to give you another static method. That uses the old I/O stuff first. Get rid of the syntax errors. This looks like a better one. Okay. So, a couple of things to note. I put this stuff in a method, and the method just takes a file name and a list of students. So it's the same as what we ended up with yesterday for when we were doing a text-based output file. Those were the same two parameters I gave. But this time what I've done with the method is I've done a couple of things here. Notice there's new file output stream. So there's this word output, there's this word file, and I've still given a file name. But as soon as I'm done with making new file output stream, it becomes the input to another constructor. Okay? And so basically this thing opens the file, and then it gets passed to the object output stream class as an open file to deal with. And object output stream, the word object is on the front. The reason the word object is on the front of there is to give you the idea that it's not writing out text-based stuff, it's writing out binary-based information. Okay? So this is going to write a binary file that consists of a list of all of the students. Okay, and so let's just try writing that thing out. All I would have to do is say write object file and give it the name of the file name, or give it the name of the file and the list of students, which was, I think, still all students. File name with a capital N. And I called it write out. Get the name correct. There we go. Okay, so if you look at the one we did yesterday, when we wrote stuff out, we said write out file with a file name and students, and we hid all of the work inside a method. I'm doing the same thing here, except I've just added basically the word object onto it, and I've written a different method. And if you look closely at the way this try-catch is written, you'll see it's a little different than one we did yesterday. The one that we did yesterday, if we go down and look at an example of a try-catch, if I can even find one, I guess it's not in this piece of code. The try-catch that we had before didn't have any of this stuff in it. It was just try, do some stuff, catch. Okay? The stuff that you see that has try with some gunk in the middle is a new Java 7 feature. And the reason that they do this is because the compiler will take care of closing the file for you. Okay? So if you go look at the previous code that we wrote, we had to do a lot of work to say, okay, we got to always remember to close the file, and we kept getting the yellow bulb saying, don't forget to do file close. In this version, when you put the information in here, the compiler is smart enough to figure out that that writer file needs to be closed, and it will just basically turn around and quietly write the code for you. Okay, so this is the new modern improved try-catch, and this is known as try with resources because it's with some other stuff on the line. Okay, so the syntax is slightly different. The bottom line for you people is that if you see old code that just has try and catch with nothing in there, then you know that it's older code. If you see code with try with something in brackets, that means it's probably the latest and greatest of the code that does the fancier thing or does the hidden features for you. Okay? That's really the only difference between the two. But notice that all my code consists of is just write out the entire list of students. Okay? There's nothing in that code that does what we did previously that plays this game of breaking students up into bits and pieces in order to write them out one at a time. All that you see is just write out the entire list of students. There's no loop, there's no nothing there. Okay. Well, let's give the thing a try and just see what happens. I'm going to change, I should change the file name here just a bit. And I'm going to call this very specifically an object file. And I'm going to call it students dot something else. I'm trying to think of what the right the official name is, but any name other than .txt will do for the moment. I'm just going to write it to a different file name so it's clear that it's a different type of file. Okay, so let's just try writing this thing out. Run it, find my files, beastie, and I'll just refresh that with wherever refresh went. There it is. And there's the students.obj file. And just out of interest's sake, can I get properties from it? Sure I can. Let's go have a look. And it's got something in it. Just want to go look at my student class again for a second and see whether or not I left something on there I shouldn't have. Nope, okay. Okay, so presumably it looks like the file has something in it. Okay, if we go and look at that thing with an editor, I can try and open it with the text editor here, I think, with open with text editor just for fun. And notice that it's got some garbage characters in it, and it's got some strings of something that don't look like anything that we're familiar with. This is a non-text file, and so when you open it with a text editor, it just looks like junk. Okay, it's got binary information and text information, and it's formatted in some way that we don't know about. Well, okay, so now all of a sudden we've got the problem that we can't actually look at the thing. So let's turn around and read it back in. And I'm going to steal some code for reading it back in. And then we'll explain the reading it back in part. Let's just get some bulbs going here. Doesn't like file input stream. That's okay. I have them in import statements up here someplace. Looks like that. There's an import for file input stream, and the other one I'm missing is object input stream, which looks like that. Just do the import by hand since Eclipse is being a little mean at the moment. And, oh, that's why it was being mean, is because I'm missing a bracket there. Okay. And just let me turn around and show you how you would use it. We would have list of student. Another copy is, and in this case what we're going to do is we're going to call read object file. So we'll just steal it from this one. Make sure I get it right. Well, I guess I just gave the file name. And the file name was that thing. And I called it read object student file. Haven't used that thing yet, but let's go look at the code. Anything interesting just from looking at this line? What can you say about what's happening inside read object student file? Creating the list, so notice that there's this concept that new is being done somewhere, not by us, but new is being done in order that we can get a list coming back. Okay? Well, if you look at the code, it's just given a file name. There's the list variable, but notice that it starts out as null, so no list has been created at this point. There's that new form of the try catch saying open the file and then take the open file and give it to object now input stream instead of output, so they're really consistent in their naming. Input is stuff coming in. So let's open the file, and there's just one command to do the reading of the information back into a list of students. So read object is actually doing the new, and it's putting that thing back into the copy of students variable, and then we're going to send that thing back. Okay? And again, notice that nowhere in this code did I do anything with splitting a student into pieces or going through the list and reading stuff. Okay? And so we'll just, oops. Before I even run that, I didn't realize I had an error there from a previous run. So it created the file, but notice that it produced an error. And so before I run the read-in part, I'm just going to rerun that thing just to double check. Oh, it's still producing the error. So it wrote out some stuff to the file, but then it had this error, and notice that it's complaining about the student class, And the error is this weird not serializable problem. So this requires a little explanation. Here's the student class. If you want the student class written out with this technique, the thing that you have to do here is say implements serializable, if I can spell it. And we'll do the import. And notice something that didn't happen when I did the import? What normally happens if you say implements something? What does Eclipse come up with? It says something like, here's a bunch of methods that you haven't added because this thing implies that you're trying to implement a standard, and so there should be some standard methods to write. But no methods were written. No methods were done. Oh, that's sort of weird. It turns out that serializable is an interface that has no methods. It doesn't, if you look at serializable and you look at the methods that you're supposed to write, if you mark something as being standard, there's nothing you have to mark. It's got no methods in it. Why would you do something like that? The reason for that is that there are times in a running program where when you want to write out information from an object, you have stuff that's runtime information that's only while the object is actually running in memory, and you've got stuff that's permanent information about the object that you want to write out to the file. Okay? So at times you actually want to mark information as being this is stuff that should be written out to a file versus this is information that I'm never going to need to write out to a file. It's only useful while the program is running. Okay? And so that little marker there says the student class is something that it's okay to write out. Okay? If you don't put that on your classes, then you can't write them out with this technique. Okay? So you end up having to say it, and that's all the work that you have to do to get it written out. That's entirely it. Okay? So now let's just give it a try. Let's just run this thing. And now the error message disappeared. And just out of interest's sake, let's go look at the size of this file. It's only 212 bytes long. It was 1,500 odd bytes long, so the file actually changed. Okay, and it got smaller, interestingly enough, with no error. Okay, well now let's read it back in. Read it back in. Nothing that we can do unless we run a for each on it. So just let me steal the for each here. And let me run it this time on another copy. And let's just see what gets produced. And I better actually put a little marker there. Just that we can see what's done. Run it again, and there's the stuff coming back. Okay, well, so we managed to get stuff back. Let's just go do one more thing, which is let's play this same game that we played here with double equals, just out of interest's sake. And I'm going to rename these to, this is, I guess, our third attempt. And this time I'm going to get this thing from another copy, which was the object version. And I guess this is Fred 40. And we'll see if Fred 30 equals Fred 40. So, still not the same. This was the original one. This is the one that we made with using read object, and they're still not identical. So we still got a copy. Oops, write it out, read it back in, don't get the same thing. Well, let's try one more thing just out of interest's sake. I'm going to go add another Fred onto here before I write it out. Did I do that right? Just looking at where I wrote it out, got to back up a little bit. Just going to play one extra little game here. I'm going to go do this, all students dot add new all students dot get okay. I'm playing a little trick here. When I'm writing out when I'm making the thing to write out, I re-added Fred. So Fred is in position 0, so he now appears twice on the list, both in position 0 and position 4. And now I'm interested in, when I read him back in, if I get the fourth person. I think that should be Fred. We'll just find out. Run with the debugger. And take a look and see who's in Fred 40. That's also Fred. But notice what the debugger is saying right away. Notice the ID number there. It's still different. So it ended up creating different versions of Fred. They're not identical. We've still got multiple copies of the Fred object, so we've still lost identity. Okay? So, quick review here of what we just did. We said another way of writing out students is to write them out as object files. Okay. If you write them out as object files, a text editor isn't going to do you any good to look at them. They'll generally be smaller than a text file. They're in some format that you don't understand. You end up having to open the file and then pass the open file to the constructor of some other routine. But when you go to write it out, you can just give, notice that's the entire list of students, and it will not only write out the list, but it will write out all of the students that were on the list magically for you without you doing much work other than having to go to the class and say it's now serializable. Okay, so I didn't have to decompose the object in any way. To read it back in, the process is basically the reverse. You call input stream beasts and you call reader's read object on the file that you opened, and that will turn around and make you an entire list of students out of the file back again, and you can basically take that copy and do what you want with it. The only hitch to the game is that when you write stuff out and read it back in, you lose the idea of identity. So identity doesn't work, you get copies of objects, and now you're stuck with is similar to or the dot equals method in order to do your comparisons. Okay? Which is why the dot equals method, writing it for classes, becomes somewhat important when if you're going along and trying to compare these objects to do stuff with them. Okay. How much stuff do you think you could write out here. Notice we wrote out an entire list. All students is a list. Think of my fishing derby, the fishing derby example we did, where we had a derby that consisted of fishermen or buckets, and the buckets all had fish within them. In that thing, if I would have marked the fish as being serializable, the buckets as being serializable, and the derby as being serializable, I could have written out the entire derby object with just one write command. And this thing would have gone through and figured out, oh, okay, a derby is hooked up to a list of fishermen. Let me write out all of the fishermen. Oh, fishermen have got lists inside. Let me write out all of the fish. And it would have done all the work of writing out all of the information for basically the entire program, all of the data that we were keeping. And then I could turn around and use this exact same code to read it all back in again. Okay? So one of the reasons that I gave this to you is that what you have here is a very, very short piece of code that will basically write out as much information as you want. You just go and write out the highest level object that you have, and anything that's underneath it just magically gets written for you. Okay? So it's a very powerful tool. The problem with it, it typically only works for local files. It's a very Java-ish thing to do. So if you're writing files out to, my laptop, right out to the actual disk drive, it's pretty handy. If you're planning on using it to transport information to some other program or across a network, then it's not so handy anymore. Okay, so very useful as a local sort of file save tool for more or less standalone Java applications. Okay, not to say that you can't move the file across the network and use it on some other computer, that will work, but it's typically not used for sending objects back and forth across the network, we'll put it that way. Okay, so an interesting little tool. We'll hold it here. How does this thing even know what's inside an object? I mean, the whole reason that we were writing out student files to begin with was because we figured that Java couldn't possibly know what was inside the student object we'd created, so we had to break it up into its component pieces of text. Well, that's really interesting. It turns out that Java stores all of the information when you in a .class file when it compiles our Java code into their object format in the .class file. It keeps a huge amount of information about what that class actually looks like. Okay, and let's just do a little example of this, of the sorts of information it stores. I've got one here. Let's just give this little piece of sample code a try. I'm going to put it in a method, actually, just because that way it simplifies my already long driver code. Oops, I put it in the wrong place. And I'm going to have to do a little trick here. Here's my little routine. This thing says use the compiled version of the student class, right? So this is something that Eclipse doesn't show you. We've only seen student.java, but it's turning, basically it's compiling student.java into a student.class file, which is the actual runtime object that gets used. The .class file has all of the information in it about what the student class looks like, what's its component pieces, what are its method names, all of that sort of stuff. And so what I've done is I've said, take that class file and we'll refer to it with, oh, now get this, the class. Okay, so there's a Java class called class, which is used to get information about classes. Did you get that? That's what it does. So this is the class of only students, so there's that of only thing with the angle brackets. But once you've done that one line, there's also a method class, which is useful for figuring out what the methods are in each individual Java class file. And so I've written a for each loop here that says go through every single method that's in the student class and give me the list of the declared methods. In this case, I'm just going to print out the method's name. Okay, and let's just run that on, let's just put print methods back up in here someplace near the end. And we'll run this thing and we'll see what gets produced. Isn't that interesting? You can go discover that the student class has those methods. It's got a get first name and get last name and a set first name and a set last name and all of that sort of stuff. Okay. Not only can you find out the names of the methods, you can find out what all of the arguments are for the methods, what the return types are for the methods, and to top it all off, you can use that method class to call methods. Okay, so you can actually go and inspect the student class at runtime without ever having written any code, go and find a set method for setting something at runtime and say, oh, okay, I can send in a string to this thing and I can change something on the fly without ever having written any code. Okay, very interesting. This is known in the business as introspection. So this idea that you can look at parts of the program or objects at runtime, you can interact with them at runtime without ever having written any code for them, and basically do whatever you want. And so what's happening here with when we do file output stream or write object, wherever it happens to be, is the code for write object doesn't care what type of thing you give it, because what it will do is it will go to that thing, it will run code like this to say, instead of looking at the methods, it will say, go show me the fields of the object. And for every data field, it will say, well, okay, go show me what type of object that is. Go let me figure out what types of data fields those objects have, and let me do the work at runtime of just writing the stuff out for you. So the description of all of that information of what the object contains is already buried inside of that class file, which means that it can go find out at runtime how to write it out. What do you think it does when it goes to read it back in? It does almost exactly the same work that we would write code for. It says, oh, okay, let me go make a new student object calling the empty student constructor. Student needs first name, last name, and age. Oh, I happen to have those pieces of data in the file. Let me go call student set first name to write out the first name field. Let me go write set last name to write out the last name field. And so it does all of the work on the fly in writing it out. So it becomes a very powerful tool because you write the code once and it now doesn't matter what type of object you give it, it will just turn around and do all of the work for you. Another example of using this, anybody seen the drag and drop GUI editors? the ones where if you want like a button, you take the button and you drag it from the palette of buttons and you drop it onto the palette in order to create some sort of GUI. Well, those drag and drop GUI editors typically have a panel that says, for a button, here's all of the fields that you can change for a button. You can, if you type text in this thing, that's the equivalent of calling set title on the button in order to have the button set. All of the drag and drop GUI editors, they don't actually write forms for every single individual type of GUI object that you can make. All that they do is they use this technique, and they're just presented with a GUI object, and they go and they make the form of information for all of the fields on the fly in order to create that sort of stuff. Okay? So the coding is really, again, really simple. You just basically, the person who's making up this GUI stuff just has to know what the GUI objects are, and they can basically extract the information about the types of things that need to be presented on the form when somebody says, oh, this is the type of object I want to click on. Okay? So there's not a lot of code that has to be written in order to do that. Okay? So that ends up being an extremely powerful tool for a whole bunch of situations where you're just presented with objects at runtime that you've never seen before, and you have to do some work on them. Typically for reading and writing files, or like I said, that sort of GUI presentation strategy. Okay. Another place where you'll see it is actually in the debugger. If you notice in the debugger, when you crack open a student object, and all of a sudden the debugger knows that a student object has a first name, a last name, and an integer value. It's never seen student before. It's not like we had to tell the debugger that the student object was somehow there, but it knows by virtue of the student class file how to pick up all of that information. Okay? So that's where it's all coming from. Okay, and we've got time for one other quick example. So let's do one more in your favorite, the XML way. And I just want to double check my student class to make sure that, yeah. Here's a method for taking the student information, same list of students, same idea, I've kept the same format, but now writing it out in XML format. And XML encoder is a Java class that's basically going to play the same game we've seen already. It's going to inspect this file at runtime. And let's just write out that information at the end of this program here. And I need to give it a file name, and I'm going to give it something that's a .xml extension. Oops. What did I? I'm just going to steal that name, and if I'm lucky, it will work. Oop, what did I do that's different? Oh, the extension isn't going to make any difference, other than that it won't be happy. A file name and all students would be nice. Okay, and let's try to write this thing out and see what happens. And it comes up with a different type of error. Notice that there's something interesting going on here. Instantiation means I'm trying to do new to create objects. So it's at some point trying to create a student, and it's trying to, looks like, add that student to an array list, and it's having some issues, not just for one student, but for all of the students I have on my list of students. Okay, well, this one is another one that requires a little bit of explanation. And it's sort of not obvious, but if I go back and look at my student class, the problem with my student class for writing out XML files is that I've got a very specific constructor in here. And the way that this XML stuff works is that it actually requires a default empty constructor in order to work. And so I'm going to make a student constructor here that takes no arguments, and it can just set everything to empty. Why do I need that one? Because the way that this XML thing works, whenever it needs to do stuff with a student, it starts out by calling the empty constructor to make a student, and then after it's made a student, it understands how to get at the first name, last name, and age variables because they all have their appropriate setters. Okay? And so the rule for using this thing is that by default, the only way that you can write something out in XML or use these XML facilities is that you have to have an empty constructor, and you have to have gets and sets for each one of the fields that you want to write out that are named exactly get and set according to those fields. Okay? And if you look at the import statement, that thing came from Java Beans something. A Java bean is something that meets the definition of having gets and sets that match the field name or match the field names and an empty constructor, which is why we've been trying to get into the habit of writing them that way. But now that we've done that, just before you depart, let's run this thing. Let's do a refresh on this. And let's look at our students.xml file. It has your traditional XML header, including the version of Java that was used to write it out. And there's that beans word that says something specific. And look what it did in the XML. It said, oh, if you want to read this thing back in again, you're going to need to put things into an array list. You're going to have to make an array list object. Then you're going to have to call array lists add method for each one, or for this thing. That thing is a student object that has an age. So that really means set age to 23. It has set first name to Fred, set last name to Flintstone, and then you need to call array lists add method to add that object in. Okay? So this XML file is basically formatted in such a way that it's the instruction recipe for how you could turn around and recreate this thing if you were doing it in Java. And it just happens to work as a standard XML file. Okay? So now that we've seen the XML, we'll read it back in tomorrow so that we can see that you can get it back in. And the joy of this thing is that you've now got a formatted text file that's transportable to any other type of programming facility across a network, for instance, into a Python program or into your lovely PHP programs, right? Perfectly usable as a transportation mechanism between all sorts of things. And with that,